Problem 20.08 says a heat engine performs the reversible cycle ABCA with 9.0 moles of an ideal gas, as shown in the figure. Path CA is an adiabatic process. The temperatures at points A and B are 300 Kelvin and 500 Kelvin, respectively. The volume at point C is 0.20 meters cubed. The adiabatic constant of the gas is 1.60. The thermal efficiency of this engine is closest to. So first we have to use this formula, this thermodynamic formula, work from AB to equal PB minus BA. So first we have to find all the sum of the works. So first I'm gonna find this one right here, and then we have two unknowns. So first I'm gonna find those. I need to know the V and the V of V and then the pressure. So first I'm gonna use VA TA equals V over TV. So I'm gonna solve for the volume of V, and then that's is volume of A times TV over TA. So now I'm just gonna plug the numbers. So 0.2 times 300 Kelvin over 500 Kelvin, and that's gonna give us 0.12 meters cubed. Now I'm gonna use this ideal gas formula, which is PV equals nRT. Then we have to solve for P, so nRT equals over V. So now I'm just gonna plug the numbers that we know. So 9 moles times an 8.314, that is a constant, times 300 Kelvin over the 0.12 we just got, and that's gonna give us 1.87 times 10 to the 5 PA. So now I'm gonna plug the numbers that I just got into this formula right here. So work of A and B is equal to the pressure 1.87 times 10 to the 5, and the volume B 0.12 minus the volume of A, which is 0.2. So now that's gonna be 1.496 times 10 to the 4 joules. So that's the work from A to B. So now we also know that the work from B to C is equal to 0. So I have two of them. And now I have to find the work from C to A, which is the same formula we used before. Work from C to A, PABA minus PCBC 1 minus Y, which is a thermodynamic formula. So I don't know the pressure of C, so I'm just gonna solve for it the same way I did before. P equals nRT over V. So 9 times 8.314 times 500 divided by 0.2, that's going to give us 8.26 times 10 to the 4 pascals. So now I can plug my information in this formula. So PA is 1.87 times, I put an 11, 1.87 times 10 to the 5 times 0.12 minus 8.26 times 10 to the 4 times 0.2, and then 1 minus 160 that it was given as well. So the work from C to A is negative 9.87 times 10 to the 3 joules. So now I can use the sum of the total works to find the total work in this system. So I'm going to use the work from A to B, that is 1.49 times 10 to the 4 plus the 0 minus this one that we just got, 9.87 times 10 to the 3. And that's going to be 5.09 times 10 to the 3 joules. So now that we know that, we have to use this ideal gas formula, which is Cp equals R y minus R. So all these numbers we already know them, so we're just gonna plug them. 1.6 times 8.3414, 1.6 minus 1. So that's gonna be 22.1. Now I'm gonna use this formula, which is Q equals N Cp delta T, and that's gonna be 9 times 22.1, 500 minus 300, and that's gonna give us 39,907 joules. So now I can calculate the efficiency, which is a thermodynamic formula, and then I'm just gonna plug the numbers. So the total work, 5.9 times 10 to the 5 over the 39,907, and that's gonna be 0.13, and that's it. That's the right answer.